Part 2. This is for questions 7 to 10. Question 7. The coordinates of the points P and Q are 1, 1, and then 7, 11, respectively. The line segment PQ forms a diameter of a circle. Find the equation of the circle. Now, I'm having my circle here, which has gotten a circle I don't know. Then we have 1, 1. So, let me say maybe this one is 1, 1, which is our P. 1, 1. Then 7 is on the right of 1, and then 11 is above 1. So maybe this one is going to be my Q, which is what? 7, 11. Now this one here is a diameter, okay? P, they said PQ is a diameter. So that means I'm going to take what? The center has to be the midpoint of the two, okay? So center, I can call it C. It will be equal to the midpoint of PQ. So we get the average of the x points, that is 1 plus 7 over 2, and then the average of the y coordinates, 1 then plus 11, then out of 2. This one will give us a 4, and then this one will give us a 6, okay? Then after that, remember, to find the equation of the circle, we need the center and then the radius. Now, here we are having 4 and then 6. That is our center. Now, I can find the radius by maybe using the P and the Q. Then after that, I divide it by 2 because PQ is the diameter. Or I can use C and Q, or P and C, then I find the radius, okay? Now, using P, which is 1, 1, and C, which is 4, 6, then the radius is going to be the square root of the change in the x, that will be 4 minus 1 squared. Then the change in y is 6 minus 1, then squared. So 4 minus 1, that is 3 squared, that will be a 9. Then plus this one will be 5 squared, that is a 25. So 9 plus 25, I think that one gives us, what does that give us? 34? Yes. So we shall get 34. So r will be equal to the square root of 34. Then that means we shall have the equation of the circle as x minus 4 squared, then plus y minus 6 squared, which is equal to the square root of 34, and then you square this. Then finally you get x minus 4 squared, then plus y minus 6 squared, and then this one is equal to 34. So this is the completed square format, okay? But then you can expand this if you have your time to waste, and then you have the expanded format, okay? And then part B, they're saying find the equation of the tangent to the circle at point Q. Now I'm going to get this circle of mine here, then I duplicate it, I take it down here. At Q, equation of the tangent. A tangent is that line that cuts the curve, or that meets the curve at only one point. So this is the tangent. Now in circle theorems, you know that the radius is perpendicular, okay? It's perpendicular to the tangent. So that means I can use C and Q, okay? C and Q to find M1, okay? So our M1 then will be changing y, that is 11 minus 6, then out of 7 minus 4. 11 minus 6, that one gives us a 5. 7 minus 4, that one gives us a 3. Then we need to find M2, which will now be the gradient of the tangent, okay? The gradient of the tangent M2 then will be negative 1 out of this 5 over 3, which is going to be negative 3 out of what? 5. You know that for two lines that are perpendicular, then the product of their gradients is always equal to -1. So I've used m1 times m2, which is equal to -1. So my m1 is the 5/3. My m2 is the gradient of the tangent I'm looking for. Then I got this, 5/3. I divided it in here. That is what you're seeing here. You see that? Then to find the equation of a straight line, we must have two things. Number one, the gradient, which we have gotten. And then next, at least one point through which a line passes. And we have that point here, Q. So using the general equation of a straight line, which is y minus y1, which is equal to m into x minus x1, then our x1 will be the 7, and then our y1 will be the 11. So we have y minus 11, then is equal to our m is -3/5, then into x minus, then the 7. So if you want, you can put it in which format? Maybe y is equal to mx plus c, or you can have a term in x, maybe plus a term in y, then is equal to a constant, whatever, because they have not told us to have a format in which we are going to express. Okay, so I can take this on this side. So what shall we have? We shall have y, which is equal to -3/5 of x, and then -3 times 7, that will be a positive 21/5, and then 11 crosses, and then it becomes a plus. So finally, we are going to have y, which is equal to -3/5 of x. Now 5 times 11, that is 55. So we have 55, then plus 21, that will be 76, not so? So we shall have plus 76, then out of what? 5. That is going to be the gradient, the equation of our tangent here. But see, the other point on the curve with the x-coordinate 7 is r. Find the coordinates of the point of intersection of the tangent at Q with the tangent at R. Now, let us go back to our diagram here. So I'm going to copy this diagram here, okay? Then I take it the other side. Now, this is my diagram here. Maybe I can take away this word tangent. Now, they are saying the other point on the circle with x-coordinate 7 is R. So if this is 7, you know those lines which are vertical are given by, I written in the form x is equal to a constant. So that means that other point has to be directly, maybe below this Q, like that. So suppose I put this R here, okay? And then the tangent at R will be like that, okay? It will be like that. So I have point R here, which is 7 what? And then the y coordinate, we don't know it, okay? So find the coordinates of the point of intersection of the tangent at Q and the tangent at R. So what I need to do is to find the equation of the line what? Of this tangent here through R. Then I solve it simultaneously with the equation of the line, equation of this tangent at Q. You see that? All right. So what are we going to have? It should be noted that if this line here, these two tangents that are intersecting outside the circle, okay, if this one has a gradient of m, then this one will have a gradient of -m. You see that? A gradient of -m. They have the same gradient, but differing in signs. Okay, so we shall say if the tangent at Q, okay, at Q is, if the gradient of the tangent, okay, if the gradient of the tangent at Q is, what did we get? -3/5. okay, is negative 3 over 5. Then the gradient of the tangent at r, which is 7y, okay, is 3 over 5. Now we need to find the y coordinate of r, okay? How do we get the y coordinate of r? Since r lies on the circle, then that means its coordinates must satisfy the equation of the circle, okay? So we have 7y, which is our r. Let's go to the equation of the circle. The equation of the circle, we got it here. X minus 4 squared, then plus y minus 6 squared is equal to 34. So we have x, our x is a 7, then minus 4 squared, then plus y minus 6, then squared, then this one will be equal to 34. So we find the value of y. This one is what? 3 squared, that's a 9. So the 9 we get from here now crosses this side. We shall have y minus 6 squared, which is equal to 34 minus 9. I think that is 25. Not so. 25. Then take the square root. Then y will be equal to plus. When you take the square root, we shall have y minus 6. This one will be equal to plus or minus 5. So take the 6 this side. Y will be equal to 6, then plus or minus 5. So y1 here is 11 when you get 6 plus the 5. And then y2 will be equal to 6 minus 5. Then you get a 1. So since 11 is already here, okay, then the y coordinate of r has to be equal to what? To 1. Therefore, the y coordinate of r is a 1. Now we are going to find a gradient, okay? Gradient of r. Gradient of the tangent. Gradient of the tangent through r is equal to what? 3 over 5. You remember here? So I will have another point on this one here, on this line r. This one is continuing, but I will have another point, maybe xy, okay? So the gradient, okay, now this one is another y coordinate, okay? Already this one we have gotten it as 1, okay, as 1. So how do we get then the gradient here? So it will be using xy, any other point on that line, and then r, which is 7, 1, okay? So we shall have change in y minus 1 over, then x minus 7. This one will be equal to the 3 over 5. So what will be the equation of r? So we shall have y minus 1, then is equal to 3 over 5 times x minus 7. So y then will be 3 over 5 of x, then minus 21 over 5, and then when the 1 crosses, it becomes a plus. So that means we shall have y, which is equal to 3 over 5 of x, and then this will be a 5. So minus 21 plus 5, you'll get minus 26. 16 over 5. This is the equation of the tangent through r. You see that? Then after that, we solve these two simultaneously. So solving, what did I write here? Solving y is equal to 3x out of 5 minus 16 out of 5. And the other one, the equation of the tangent here was negative 3 over 5 of x, then plus 76 over 5. And y is equal to negative 3 over 5 of x, then plus 76 over 5. So we shall just equate these two. So 3 over 5 of x minus 16 over 5. This one is equal to minus 3 over 5 of x, then plus the 76 over 5. So when we multiply all through by 5, the 5 will go in the denominator. Okay, so we shall have 3x then minus 16, which is equal to negative 3x, and then plus 76. Bring this one here, it will these ones will add up, so we shall have 6x then is equal to, take this 16 this side, 76 then plus 16, this one will give us 12, then take 1, that is 92. Not so. We shall get 92, 92, and then x will be equal to 92 divided by 6. This one can be simplified to by 2, 46 by 2, 3. So we shall have 46 over 3. That is the x coordinate. And then we need to get the y coordinate because they said coordinates. So we must have the one of x and then the one of y. Then y shall be equal to, you can substitute here or here, whichever you want. So suppose I substitute in this one here, that is minus 3 over 5 of our x is 46 over 3, then plus the 76 over 5. This one will cancel with that. Then we shall have a negative 46 over 5, then plus the 76 over 5. Not so? Let me write it well here. So this will be negative 46 over 5, then plus 76 over 5. So 76 minus the 46, we shall get 0. Then here a 3. So that will be 30 over 5, which is what? A 6. So that means the coordinates of the point of intersection are going to be 46 over 3, then 6. Okay, and that is that. Question H. The first three terms of a geometric progression are a, b, and c respectively, where a, b, and c are positive constants. The first three terms of an arithmetic progression are a, b, and then minus 3c respectively. But a, show that this is that. Okay, now for the GP, we have the first term, and then this is the AP. So if for the first term you have it as A, then the second term you have it as AR, and then the third term, okay, you have it as AR squared. That means for us to get the next term, we get the previous term, then times R, not so? So that means for me to get the common ratio, I get, let's say, the third term, I divide by the second term, or I get the second term divided by the first term, not so? So this is what I'm going to write here. The common ratio R. So R is going to be equal to the second term, here it is B, then out of the first term, okay? Then this one is the same as we have the third term, which is C, then divide by the second term, which is B. You see that? So if we can cross multiply here, then we can get B squared, which is equal to AC. I can leave that one there. Now for the AP, we have the first term as A. Then the second term, we have it as A plus D, not so? Then the third term can be A, then plus 2D. That means I'm always adding a D to the previous term, not so? So meaning the common difference here is going to be the third term minus the second term, or the second term then minus the first term, not so? So I'll say the common difference D, this one is going to be equal to the second term, which is B minus A, has to be equal to the third term here, which is minus 3C, then minus the second term, which is b. Okay. So here I think what I didn't add on, just like I said here, so it has to be the common ratio r has to be that. Now here we have sc is equal to b squared over sc. Now here we can make maybe b the subject of the formula, not so? We make b the subject of the formula because even here we are not seeing b and c. So b squared is equal to that. Then you come to this one here, bring this b here. You'll have b then plus the other b, then is equal to minus 3c, then plus a, not so? Because when this one crosses, it becomes a minus. So 2b is equal to minus 3c plus a, or I can write it as a minus 3c. Now, b here will therefore be equal to a minus 3c out of 2. Then b squared will be, you get the whole of this squared. So a minus 3c over 2 squared. What does this therefore mean? It means that AC here, which is our b squared, then is equal to this one here. That is a minus 3c out of 2, then squared. Now we solve this. So we have SC, which is equal to, this is a minus 3. So let us square what is up here. We shall have a squared, then 2 times a times minus 3c. That will be minus 6ac. And then square the minus 3c, you get a positive 9c squared. Then we divide by, square this one, it will be a 4. So when you cross multiply, you will have 4ac. Then this one will be equal to a squared minus 6ac, then plus 9c squared. Now I'll bring everything this side such that I have a quadratic in a. So we shall have a squared minus 6ac, then minus this 4ac, then plus the 9c squared. So meaning, of course, this one will be equal to 0 because this one was taken this side. So meaning we shall have a squared minus 10ac, then plus 9c squared, which is equal to 0. And this is exactly what they told us to prove. And that is that. It is now given that a is equal to 9 and c takes the smaller of its possible values. Okay. B Roman 1, find the sum to infinity of the geometric progression. So what do you think we are going to do here? We are going to just substitute, I think, in here. So if a is equal to 9, then we shall have 81. Okay, substitute here. Then put 9 here. Okay, maybe let me show the substitution. 9 squared minus 10 times 9, and then times c, then plus 9c squared is equal to 0. So meaning, from here we are going to get the quadratic in c. So that is 9c squared. This is minus 90 of c. And then this one is what? Positive 81, which is equal to what? 0. Divide all through by 9. That means we shall have c squared minus 90 divided by 9. Isn't that a 10? So 10c, then plus 9. Two numbers, when multiplied, they give us positive 9, but when added, they give us negative 10. That will be negative 1 and negative what? Negative 1 and negative 9. So we have negative 1 and then negative 9. So meaning c will be equal to 1 or c will be equal to 9. But they said c takes the smaller of its two possible values. So therefore, c has to be equal to what? To 1. You see that? Then they want the sum to infinity of the geometric progression. So the sum to infinity is given by a out of 1 minus r, not so? So we need a, the value of a. Okay. Now we have something here, b squared the value of A is given as a 9, okay? Then we need to find the value of B. Or I can just take this one here. Since I have the value of A, okay, I need to get the value of B, by the way. Okay, now we shall have B squared from B squared, which is equal to, up here we saw that B squared is equal to AC. So we have here AC. Then my B squared shall be equal to, A is given as a 9, okay, 9. Then times the C, we are getting it as a 1. That means B will be equal to the square root of 9, which is equal to 3, okay? Of course, here you are having plus or minus, so this is plus or minus 3. But remember, they said that here, A, B, and C are positive values. So that means I'm going to take my B as a positive what? 3. You see that? Now, the common ratio. So this implies that our common ratio R, remember, it is either B over A or C over B. So B over A is what I'm going to take. So my B is a 3. Then out of the A is a 9. Not so? And then this one will become a third. Now, sum to infinity is this one here. So my sum to infinity, which is equal to A out of 1 minus R, my A is a 9, then out of 1 minus a third. So this will be 9 out of 2/3. This one will go up and multiplies with the 9. Then we shall have a 27, then out of 2. That is our answer here. Then Roman 2, find the sum of the first 20 terms of an AP. Now, we need to get an A, and I think it is the same. The first term of the AP is this, the A. Then we need to find the common difference, okay? So the common difference is either B minus A or minus 3C minus B. So I'm going to use B minus A, okay? Now, from the common difference, D, which is equal to B minus, is it B minus A? Yes, B minus A. Then this common difference is going to be the value of B we have gotten from here is a 3, okay? 3, and then the A is a 9. 3 minus 9, that means our D is going to be what? A negative 6. Then we know that, of course, our A is what? A 9. Sum of the first n terms of an AP, it is n over 2 into 2A, then plus n minus 1 of D. So if we are saying sum of the first 20 terms, that means n is 20. So then 2 times our A is a 9. 20 minus 1, that will be a 19. Then times our D, which is negative 6. And then here we shall have a 10, then 18, and then 19 times 6 here. Of course, we shall have a minus. 19 times 6, that one is 114. Then altogether, the sum of the first 20 terms of the AP is going to be equal to what? 10 into 18 minus 114. Our answer is negative 960. Question 9, the function f is defined by this for x greater than 2. Because if x is 2, that means you have a 6 minus a 6, that will be a 0. Then squared, of course, that's a 0. So any number divided by 0 is undefined. So the function becomes discontinuous at x is equal to 2. That's why the 2 was eliminated. So you can consider values on the left of the 2 and then also on the right of the 2, okay? But now they only want on the right of the 2. Now, part A, find an expression for the f prime and hence determine whether f is an increasing function, a decreasing function, or neither. Okay, so our f of x is going to be 4. Then using rules of indices, I'll take that one up. Then we have 3x minus 6, then to the power of negative 2, then plus again 3x minus 6, and then to the power of negative 3. So f prime of x, now we are differentiating, so drop the power here. You'll have the 4, then times the negative 2, and then 3x minus 6. Reduce the power by 1, so this will be negative 3. Okay, and then times the derivative of what is coming from inside here, which is a 3, using the chain rule. Then plus, drop this one here, you'll have negative 3, then into 3 of x minus 6, and then to the power of negative 4, because when you reduce this by 1, it becomes negative 4, and then times the 3 that comes from the derivative of what is inside there. So this is 8 times 3, that is what? 20. 24. Okay, so we shall have negative 24. Then we divide it by, using rules of indices, I can take this one down again. So that will be 3x minus 6, then cubed. And then this is a minus 9. So minus 9 out of 3x minus 6, then to the power of 4. Now, since the x values we are going to get here are all positive, so whatever will be here, let's say anything that is greater than 2. So let's say we put 3. So 3 times 3, that's a 9, minus 6, you get a 3, not so. So this one is going to be positive, this one is going to be positive, and then you have a minus here, and then a minus here. That means the whole thing is going to be a minus. So the function, therefore, is going to be decreasing. Okay, so you have to conclude like this. 4x greater than 2, then 3x minus 6 cubed will also be greater than 0. Then 3x minus 6 to the power of 4 will also be greater than 0. This therefore implies that the f prime of x will be less than what? 0, because of this minus and this minus here. Okay, yeah, I can even put this as 1. Maybe that is even better. Let me just simplify this one here. So we are going to have 3x, then minus 6 to the power of 4, because this one goes in here, right? Now this whole thing divide by this, that means 3 of them will go, then we remain with 1. So that is minus 24, then times 3x minus 6, okay? Then, or in other words, you multiply here by 3x minus 6, and also here 3x minus 6. So this one will become power 4, just as this one. You see that? So that you have the common denominator. Now, of course, here we shall have minus 9. Now, simplified, we shall have this one. Minus 24 times 3. What do you get? I think that's a 72. So minus 72 of x, then plus minus 24 times 6. 24 times 6. That one gives us 144. So you have positive 144, then minus a 9, then 3x minus. This is 3x minus 6, then to the power of what? 4. And then we have negative 72 of x. 144 minus 9, what do we get? 144 minus 9, what do we get? 144 minus 9, we get 135, so plus 135. Then out of 3x minus 6, then to the power of 4. That is our f prime. Now, for x greater than 2, here, any value you are going to multiply in here, this one is going to be greater than 144, because if this one you multiply it by 2, you get negative 144, then plus the 135. Already this one is positive. I mean, already this whole thing will be a negative. So now a value that is greater than x will give a much more negative what? value. But this one here will always be what? Positive. So for x greater than 2, we shall say that this 3x minus 4 minus 6 to the power of 4 will always be positive. Okay? And then this minus 72 of x, then plus the 135, this one will always be less than 0. So if you get a negative, okay, then divide by a positive, what do you get? You always get a what? A negative. So this therefore implies that f prime of x will always be less than what? 0. You see that? Hence, the function has to be decreasing. Hence, decreasing. So that is that. Then part B, state whether the inverse of this function exists. Give a reason for your answer. The inverse only exists if a function is 1 to 1. Okay? So if x is a decreasing function, it is continuing to decrease. Okay? It doesn't have a turning point. That means each x coordinate corresponds to, gives one y coordinate. Okay? So it is decreasing. So it makes it a one-to-one function. But if it was, let's say, having a turning point, it was decreasing, and then at one point, then it was increasing, then that means two x coordinates could give one y coordinate. You have x2 here, and then you have y1 here. You see that? So since the function is constantly decreasing, then it is one-to-one. So I will say f inverse exists because the function decreases continuously, hence making it, in fact, even if you stop here, f inverse exists because the function decreases. You are done. Hence making it 1 to 1. And a function can only have an inverse when it is 1 to 1. So that is that. The function g is defined by g of x, which is equal to 4x minus 3 for x greater than a. But find the range of g in terms of a. Range of g in terms of a. Now, this one is continuing to do it. This one is a straight line, so it goes like that. So if you put 2 here, for x is equal to 2, because x is, a is 2, I think. Isn't it the same? Don't they share the same? Okay. Did they give us a? No. They said for x greater than a. Now, because this one is a line that is increasing like that, okay, the value of x you put in here will always give you the bigger y value, okay, because this one is always increasing. You see that? So let me actually put something like that. This is y, which is equal to 4x minus what? 3. So it cuts y-axis at y is equal to what? -3. Not so? So if I can maybe just represent it like that, it can make sense. Let me just stop it there. This is x, this is your y. This is at -3. Now, as x increases, even y is increasing. So when you put in a here, it will correspond to a certain y value. So if this is a, maybe I'm just assuming a is here, so it will give us a certain what? Y value. Okay. Now, a and above will give us y values which are also going to be greater than the y value you are going to get here. Does that make sense? Okay. Now, we shall say for x equal to a, then y shall be equal to 4 times a minus 3, which is 4a minus 3. So that means the range of g then will be given by, so it is starting from this value here. So we have 4a minus 3. So the g of x has to be greater than that. And remember that the range is given in terms of the function, but then the domain is given in terms of the independent variable, for example, x. So that is why you're having this one here. So this is the domain of the function, and then this is the range. Then part D, find a set of values of f for which the composite function g exists. For which the composite function g exists. So f, for f of g to exist, okay, for f g to exist, okay, then the range of g must fit into the domain of f. So what do I mean here? We are having a set of values here. Let me put this one down. We are having a set of values of x here. So g acts on those values, then what comes out is the g of x. Then f acts on the result, okay? Then we have f g of x. But remember, a set of input values for the function, that is its domain. So this one is going to be the domain of g, because these values are put in what? In g. Then what we are getting here out is the range of g, okay? But now since f here is the one that acts on the result, then whatever we put in f must be its domain. So here we must have the domain of f, and then what comes out will be the range of f. And so now I can just do like this, from this to that. That will be the f of g. Now the domain of f, let us look at the domain of f. Domain of, okay, range of g. Let me begin with the range of g. Range of g, we have said it is 4a minus 3. So g of x has to be greater than the 4a minus 3. Then, in other words, the range of g is given by this expression here. And then the domain of f, what was it given as? Domain of f, when we check behind here, it is x greater than what? 2. So it is x greater than 2. Now you get this expression here for the g, and then you put it in the x. So this implies that we shall have 4a minus 3, which has to be greater than what? 2. Now you have 4a greater than 2 plus 3, and then 4a will be greater than 5. That means a has to be greater than 5 over 4. So this will be the set of values of a for which this one will exist. Does that make sense? All right. Question 10 is coming from circular measure. They are saying that the diagram shows a circle with center A and radius R passing through points B, C, and D. A larger circle of radius S has center C and passes through the points B and D. The length BD is also S. Okay, so this is the big circle, okay, and its radius is from D here to C, that is S, which is the same as from C to B here, which is also S, okay? Then for this smaller one here, the radius is from this point A here, that is A to C here, which is the same as this one here and also this one there. Okay, now what do they want in part A? Show that S is equal to root 3 of R. Now I want us to look at this triangle here, BCD. This is S, this is S, this is S. It is an equilateral triangle. That means this angle here is equal to this angle here, is equal to this angle here. Not so? Which has to be 60 degrees, which is 2 pi over 3. Because remember here, we deal with angles in radians. So I will say, since triangle BCD, is equilateral, then its interior angles are all equal to 2 pi over 3. Now, S in terms of R. For a triangle which is not right angled, because you can see this triangle is not right angled, okay? Then we can use a cosine rule if all the 3 sides are given. You see that? So the 3 sides are given, and then we need an included angle here, which we have it as 2 pi over what? Over 3. So I'll write here 2 pi over 3. Now, if this one is 2 pi over 3, I want you to look at these triangles. This one is divided into 2. This one is R into 3. This one is R, this one is R, this one is R. Now, all of these 3 triangles are congruent, okay? This triangle here is the same as this, is the same as that, not so? That means the angle also here is the same as the one here, and that's the one here. So that is, let's say 3x is equal to 360. That means this one will also be 2 pi over 3, which is 120. So each of these angles is 120. So we have 2 pi over 3. Also here, 2 pi over 3. Also here, 2 pi over 3. Now, we need to get this angle here, which has to be the same as this angle, because this one is the same as this. It's an isosceles what? Triangle. You see that? Now, angle, I will say angle ADC. ADC. This is A, D, and then C. Angle ADC is equal to angle ACD, okay, which will be pi minus 2 pi over 3, because angles in a triangle sum up to what? 180 degrees, which is pi. Then we divide by 2. Now, this will be 3 pi minus 2 pi, so that will be pi over 3. Then divide by 2, that will be pi over 6. Pi over 6. Or in other words, we could even just divide this one by 2, because you can see that this AD, okay, is an angle bisector of this 2 pi over 3. It's the same here. Pi over 6, 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 pi over 6. You see that? So I'm going to write here pi over 6, and also here pi over 6, like that. Then after that, we can say, now we have our triangle here. Okay, we need to find what? Since I know now all of these angles, I know this, I know this, I know this, and also the sides, then I can use sine rule or cosine rule. Now I'm going to use both of them. Okay, yeah, using sine rule, because a triangle which is not right angled, we can either use sine rule or cosine rule. Now, we have the R here, and then this angle. Then we also have S, and then this angle here. Okay, so we can have what? The side is S. So S, then out of sine of the angle that is opposite to it, which is 2 pi over 3, then is equal to, then the other side is R, then sine of the angle that is opposite to it, which is pi over 6. So R, then out of sine of of pi over 6. You see that? What do we have here? Sine of 2 pi over 3. 2 pi over 3, that is 120. It is in the second quadrant. And 180 minus 120, that is 60. So it is the same as sine of 60, which is root 3 over 2. And then this is r. Then here we shall have a half. So when we cross multiply, okay, this one will somersault, and then we shall have 2r. So meaning s is going to be equal to 2r, then times the root 3 over 2. So this 2 will go, root of 3r, and that is that. Then alternatively, using the cosine rule. So using the cosine rule, what shall we have here? We have a side here, s, and then the angle opposite to it. So we can say s squared is equal to, then the other two sides that are forming the angle that is opposite to this s, we have this r and then this r here. So we shall have r squared plus r squared, then minus 2 times r times r, then cosine of the angle that is opposite to s, that is 2 pi over 3. Then s squared shall be equal to, this is 2r squared, then minus 2r squared, cosine of 120. 120 is in the second quadrant, so where cosine is negative. So that means we shall get a negative answer here. And cosine of 120 is the same as negative what? Cosine of 120 is negative cosine of 60, which is negative a half. Okay, negative a half. You can press this in the calculator, no problem. So my s squared here will be equal to, this is 2r squared, then plus, this one will cancel with that, and then you will get r squared. So therefore s squared will be equal to 3r squared. Taking the square roots on both sides, then we shall have the square root of 3r squared. And this one is the same as root of 3, then times the root of r squared. So root of r squared will give us r. That means s will be equal to the root of 3, then r. As simple as that. So you choose the one that is easier for you. Part B, find an expression for the area of the shaded region. Give your answer in this format here, where a and b are constants to be found. Now when we get back here, the shaded region is this one here. Okay, so this is what we are going to do here. If this is the area of the shaded region, I can take area of this sector BAD, this whole area of that sector, then I put off area of this triangle. Okay, this area here. That means I will be getting the area of the shaded region and this unshaded area here. Are we there? Then next, I can find, let me change the color. I can find area of this sector here. Okay, remember the center is here and this is for the bigger circle now. So I'll get area of this sector, then I subtract area of this triangle here. Do you see that? So when I put off area of this triangle, that one will now give me the area of this smaller one here. That means to get the area of the shaded region, I get the first one I got, then minus this second one here. Then I will be getting this one here. Okay, so now we are beginning with area of this sector BAD. Okay, area of sector BAD. Let's go find. Now you know also that area of the sector is a half r squared theta. Okay, so I begin with area of sector BAD. So that is a half times r. Where is the radius for this smaller circle r. So we don't know the radius, but r squared, I will leave it there. Then we have the angle here, 2 pi over 3, okay? R squared, and then 2 pi over 3. So this one will go. Then we have our answer here as pi over 3, then r what? Squared. I'll keep that. Then I will need to find the area of the triangle. Which triangle? This one here, BAD again, okay? Area of the triangle, BAD. This is a half. If you know the two sides that are forming an angle, A and B, then the area of that triangle is a half, then A times B, then sine of the angle that is in between, not so. So we shall go back to our diagram, and then we look out for the two sides that we know R and also R here, then the angle in between. So that is R times R, then sine of pi over 3. This will be r squared over 2, then sine of 60, no, it is actually 2 pi over 3. So sine of 120 is the same as sine of 60, which is root 3 over 2, not so. Root 3 out of 2. Then here we shall have root 3 out of 4 of r squared. I will also keep that. Then that means if we subtract these two, okay, we shall have, I'll say the difference. So let me actually say area now of the sector. Area of segment. Which segment are we looking at? When I get this area here, then minus that of the triangle, then the segment is going to be this one here, okay? Area of that segment, BD. Area of the segment, let me add here BD. Then is going to be equal to area of the sector, which is pi over 3r squared, then minus area of the triangle, which is root 3 out of 4 r squared, which I can write as, put r squared here, and then we have pi over 3, then minus root 3 out of 4. Then after that, what are we going now to find? I said we go to, if you can remember, area of this sector here, then minus area of this triangle here. Then it will give us this one here, okay? So we shall get area of big sector. Area of big sector. What is that sector? It is BCD. Big sector BCD. Then it is equal to a half r squared. What is the radius for this big circle? It is S. So it is S squared. Then the theta here, the angle here, if this is our sector, no, pardon me here, if this is our sector here, then the angle we are looking at is here, not so? So implying that we are going to have an angle here, which is also pi over 6. So these two added will give us pi over 3. Okay, 30 plus the 30, we get the 60. So then times the angle, in fact, let me write it like this, pi over 6, then plus pi over 6, which is pi over 3. That means we shall have this one. I'm going to express it in terms of r, okay? Because they said that this one has to be in terms of r. Now, we also found here that S is equal to root 3 of r, not so. So we shall have a half, then root of 3 of r, we square that, then times pi over 3. And then this one will simplify to, what do you have here? This one will be a 3, okay? Then it cancels with that 3. Then you will get pi r squared over 2, okay? So pi, then r squared out of 2. Then from there, we shall get area of triangle, big triangle, area of big triangle. Which big triangle is this one? It is BCD, okay? BCD, that is a half times the two sides we know. We have S and then S. So that will be S, then times S, sine of the angle in between, which is pi over 6, then plus pi over 6, okay? Now this is S squared, so it is also a half, then root of 3 r, then squared, and then sine of 60 is root of 3 over 2. When I square this one here, it will be a 3, so we have 3 here, then root of 3, then out of the 2 times the 2, that will be a 4, then r squared. Then we shall then get area of the area of segment in the big triangle, area of segment in big, not in the big triangle, in the big sector, so in the big circle, or maybe I can say in the big sector. What do I mean? I'm finding area of which segment? This one here, this segment here. You see that? So I'm getting area of this segment minus area of this triangle. Now, this one will give us the pi r squared over 2, then minus the 3 root of 3 over 4 of r squared. If I can factorize out the r squared, then we can have pi over 2 minus 3 root of 3 over 4, okay? Now, after that, since we have gotten the area of this one, and we also got the area of this whole thing, that means the shaded area will be equal to the area of the segment we got at first for this smaller one, okay? Then minus this other one we have gotten, okay? So therefore, area, it is shaded area then shall be equal to the one that we got at first, the area of this segment here, this one here, then, and this one here. So in fact, let me underline them. They are the ones that I'm going to use here to get the final answer. So r squared into pi over 3, r squared to pi over 3 minus, then root 3 over 4, then subtract. We have here r squared into pi over 2 minus 3 root 3 out of 4. Now pull out the r squared, then we have pi over 3 minus root 3 over 4, and then minus pi over 2, and then plus, because the minus affects the minus here, and then we shall have 3 root 3 over 4. Now we simplify this. We can have r squared. This is 60 minus 90, that is negative 30. So we shall get negative pi over 6. And then here you have 3, then minus 1, you get 2. Then 2 over 4 is a half, not so. So we shall have plus a half root of 3. So meaning we shall have, now let us look at our format. Isn't that the format? A plus b pi. So a plus b pi. Then this one is going to be your a, root of 3 over 2. Then the b is minus 1 over 6. Okay, minus 1 over 6 of pi. Then r squared. So that means our a is root 3 over 2. And then our b is negative 1 over 6. So that is that. So this has been it for this paper. Thank you so much for watching. May God bless you. If you find the content very helpful to you, kindly like, share, and even subscribe. See you in the next videos.